Have you ever met a couple that you would describe as codependent? These are people who seemingly can't cope with the minutia of life, much less the more substantive issues of life, without having each other. And I'm no psychologist, but we generally think of codependency as an unhealthy relationship. Why? Well, Wikipedia says excessive reliance on other people for approval and a sense of identity leads to all sorts of issues for humans. They become enablers for each other with regards to substance abuse like alcoholism, drugs, gambling addictions, but also can be less overt like immaturity or irresponsibility or even underachievement. Now, I don't want to overextend this analogy, but objects can form unhealthy relationships with each other as well. And so you and I need to kind of play object whisperer or object marriage counselor as we design the interactions between our objects. Now, some dependency is completely necessary. In fact, we've been making the case this entire course about the fact that no object is an island unto itself. Objects should and must collaborate together. But when a relationship becomes unhealthy is when we begin to notice certain telltale signs of unbreakable codependencies, which in programming circles is known as coupling. So we should strive to design objects that have low coupling. In other words, objects that implement healthy relationships with other objects. And the most obvious sign of an unhealthy relationship is when we notice that one concrete object is directly creating an instance of another concrete object in order to collaborate with each other. Now, that could be a healthy relationship if the two objects are living in the same neighborhood, like we discussed several lessons ago, remember, with the boundaries. So from a domain responsibility and application responsibility perspective, if you have two objects in the same domain responsibility and in the same architectural layer, then you probably are okay. But if two objects are engaged in interboundary relationships, and one's creating a concrete instance of the other one using the new keyword, then you might have a problem, and you probably want to break that dependency. So what's really the problem here? Well, the first scenario of two that we'll look at is when a domain-specific object has a direct dependency on an application-specific object. We'll look at an example of that here in just a moment. And when you do that, we violated the separation of concerns principle. In this particular case, violating the separation of concerns principle is problematic because our domain layer is now permanently bolted onto a implementation of our persistence layer, okay? Because we've used the new keyword to directly create a concrete object from one layer in another layer. And so this will limit us in several different ways. First of all, it's going to limit us our ability to swap out implementations of our persistent objects, which in turn limits our ability to unit test our domain object. And grow confident in its ability to implement the fine print. All right. So as you can see on screen right now, I have a highly coupled example. We'll come back to this example in the very next video, and we'll solve it through inversion of control and dependency injection. We'll come back to that in a minute. All right. But let's look at the problem. So here we have a car object, which I would classify as a domain object. This is merely interested in the problem domain of describing a car. All right, it's a very anemic example in so much that it doesn't really do that much. But we see that it does have a save method where it's creating a new instance of this other class called car persistence to file. Now, this is what I would call an application-specific object. This object would probably live in another project in our solution. It would typically be a class library that we would assign the responsibility of being a persistence layer. All right, so from an architectural standpoint, you typically wouldn't have these in the same file. Since this is such a simple example, I kept them in the same file. But you have two fundamentally different concerns. One is domain, one is application specific, right? And so what this will do is the car has a save method, and in this case, we've implemented it in such a way that we created a new instance of this and created an interboundary relationship by gluing together our domain class with our application specific class to actually then persist it to the disk. All right, and so then in static void main here, we're creating a new instance of car, and we're saying, car, go save yourself, right? And then tell us when you're finished. And the result is fine. That's not really at issue here. If we see here, we just get a simple finished message, and then I'm going to pop open my C drive and take a look at, what did I call this? Oh, coupling example, I guess. And here's the car, and it prints out correctly the details of the card screen, so that's kind of cool. But the problem with this, so hopefully you can already tell where I'm going with it, is that if we ever want to replace the way that this class is persisted, maybe we don't want to save it to a file. Maybe we want to save it to a SQL Server database or a MongoDB database or a MySQL database. Well, that's going to be kind of hard to do because we have glued our domain class directly to our persistence. They're across boundaries, and yet now they have a weird codependency where one has to be there for the other one to work, and that's bad news. All right. So again, that's the case where we have a domain-specific object that's tightly coupled to an application-specific object that's in another architectural layer, and hopefully you can see where that's bad. But what about two domain-specific objects that just happen to be in two different domain responsibilities? So you have a domain-specific object in accounting and a domain-specific object in tax, and the accounting object creates an instance of tax. In that case, is that bad? Can we do that? Well, you certainly can do it, just like we can do that here, but it's still undesirable. That kind of coupling will shorten the lifespan of the application whenever you have new or different ways of communicating. But furthermore, we're not able to isolate that particular domain object, the tax object or the accounting object, for the purpose of unit testing, or we would have to go to great lengths in order to, stub out or fake out one or both of them in order to ensure that they are in fact implementing the small print of the contract, right? So we think it can do its job, but what if it's only doing its job because in our testing scenarios we've never been able to isolate what actually could happen in the real world? What if it's never been given bad data? So sometimes it's difficult to set up integrated tests between interboundary layers, and that's why it's so important to make sure that there's not these strong, high coupled objects. Not just because we may want to switch out an implementation, but then also because it makes it much more difficult for us than to actually isolate and unit test each of the individual objects. And so the way that translates into, why that's a bad thing is we're no longer to trust the object as changes are introduced into the system. Even changes in other parts of the code base could have unintended consequences on our object that's under test, without some way to verify that any updates to our code, or even when that update wouldn't seem to impact our code, and just not having that degree of trust reduces our ability to confidently say that we can guarantee the results whenever we get guaranteed inputs. So we can see that high coupling across domain or application specific object boundaries is problematic because it makes our application brittle and untrustworthy, and furthermore we're not able to swap out implementations. So coupling across domain responsibilities can be problematic. Anytime you're going to cross two neighborhoods and create, as I say here, use the phrase new as glue, you potentially have an issue. So why is this relationship unhealthy? I've stated in several different ways. Let me come at it from a different perspective. The single responsibility principle, the S in SOLID, it states that our object should have only one reason to change. So inside of a given domain responsibility, we might be automating or enforcing business rules related to that specific domain responsibility, such as marketing or accounting or tax or inventory or whatever the case might be. If objects in two distinct responsibilities, again, accounting and tax, need to collaborate for a transaction, and we create a strong dependency between those two collaborating objects, what happens whenever new tax laws are implemented by a government agency? Well, it should only affect tax, but now since it's highly coupled to accounting, chances are we're going to have to go on and update accounting as well. All right, so you can see that there might be multiple reasons why we can identify, or multiple reasons why high coupling is a bad idea, coming at it from several different perspectives. The real question at this point, if I've convinced you that this is a bad idea, is how do we break that unhealthy relationship between the two objects? How do we break up that relationship? We'll talk about that next in the next video. See you there.